All right, I should be live. So, welcome to WorldQuant Office Hours, Unit 1, Week 8, the last office hours for the session. Hopefully, people are wrapping up their mini project work. All right, I should be live. So, welcome to World. And with
Janet, the
that said,
extra.
oops, I clicked on something by accident. Let's go and try that again. Okay. Oh, yep, last office hours. Soon Johnson. Hello, Soon Johnson. Welcome to Office Hours. All right, let's see who else is joining us today. I see Timur is here. Hello, Timur. Hello, Tom. And thank you for the confirmation that the sound is working and it's all fine and dandy. All systems are checked to go. Hope everyone is doing fine and wherever they're located across the globe. I am doing fine here. Wearing my Fair Isle sweater. It's cold where I'm at. In fact, right, let's go ahead and see what the temperature is if I go and visit our application. Let's see, what do we call that? Right, if I visit our application, let's see what it tells me the temperature is. It takes a while since I'm using the free tier, so if it hasn't been spun up, hasn't been called in a while, it is a little slow. So it's about 6.5 degrees Celsius where I am at, which, yeah, makes sense. I see Lyndon Smith is here. I see Naya is here. Welcome to Office Hours, last one of the, I was going to say semester, last one of the cohort of the session. Let me know anything you want me to talk about for this last session. All right, let's go ahead and, yeah. Finish off strong, I guess. Finish off strong. Okay. So let me know if any additional topics you want me to discuss today. All right, it's got to be today. It has to be today. If I go into the repositories I have in my personal GitHub account. Here is the WQU project. So if you were following along the past few days, we have our project being hosted on my GitHub, on my personal GitHub. And what I did is I created several documents. I created the license, I created the code of conduct, how you should conduct yourself, and also a contributing file. This file here outlines how you contribute to this project. Anyone who is in this session of WorldQuant Unit 1 is free to contribute to this project. And one of the things, if you go into here, if you go into issues, I've created a set of issues that need to be resolved, are sort of good. Some of them I've labeled as good first issues. These are things that perhaps if you want to contribute to the project to take a look at, and perhaps you'd like to tackle one of those. So I have that set. I see Timur is asking, do you have any books to improve in data science? I have some suggestions. In fact, I will post that on the forum perhaps tomorrow. A set of books that I like for data science. So I will do that tomorrow, sometime tomorrow. All right. So take a look at these issues. If you want to tackle one of those, by all means, go for it. Or if you want to create your own issue, you do new issue and outline your issue and what you plan to do. So the project is now open to suggestions. If you look at what I've also done is I've added a README. A README here is just basically explain the project, how to run it locally, how to deploy it on Heroku. All those sets of instructions are in the README. Future work suggestions and contributions. So if you do contribute, I will put your username on this list of contributors. All right. In fact, I did a couple other changes, so I do want to talk about some of those changes I've made to this project. So I will show you how we can easily look at that. I see a couple of things here in the chat, so I will address it. Someone is asking, how do we know if we have completed Module 1? Well, one of the things you should do is if you go onto your pod and you go onto, let's say, Control Panel, and you go into Grades. this should be all your grades for the course. And you'll have to make sure that you have all of them solved, all of them taken care of. So go ahead and do. Looks like I haven't finished all of them. Apparently I got, it looks like I got some more to go. But please look at the grades tab. That's where you can see whether you answered all the questions. And there should be a total of 22 questions. There should be a total of 22 questions. So make sure in order to get your certificate that you score at least greater than 0 in all 22 questions. And if you want the with honors with distinction, make sure you score a 0.9 average or greater. So please, please, please do make sure, look at the grades tab for that information. I see Lyndon Smith is saying, I zip my PODS data course files via the command line, but it fails every time I try to download it. That should not, let's see. Right, if I go into my server, and I go into new terminal, I see what happens when I try to do it. And I say, let's say tar compress data cores dot tar dot gz data cores. Let's see what happens there. And there it is. Click on that. It's about 60 megabytes. Let's see what happens when I download it. It's going to take about, if you see my browser right there, it's going to take a bit of a time. I'm not sure if you see it, but according to my browser, it's going to take about 3 minutes. So maybe having a faster connection might be the issue. Maybe it's timing out. Maybe your browser's timing it out because it's too big of a file. What you could do, if that's the issue, you could create several chunks. You could partition it into several chunks and then download it that way if you're having issues. All right, I see Paulo is here. Hello, Paulo. I see Johnson is saying, how should we go one about analyzing data in an environment where data management is very poor or where one may have to make efforts to source the required data by oneself? How should one go about analyzing data in an environment where data management is very poor or where one may have to make efforts to source required data by oneself? Yeah, and I think if that is the case where data is poorly managed, then I think one of the things you could do is, it depends on like if this is within your organization or if this is just in general, is perhaps I'll lead by example, right? Perhaps suggest suggest to hires up or the people who control sort of the data collection, data processing, that this data is ineffective, is not of use because it is poorly managed, it's not well documented, it perhaps has errors, and there is no gain from that data. And I think proposing a plan of where do you store the data, any processing that is involved, might lead to better management, better understanding. I think the point here is getting people to align with the fact that unless data is properly managed, it's not going to be yielded effectively. So I don't know who those stakeholders would be in your situation, but I think it's convincing them of not only is data important, it's data that is properly managed. And I know that's easier said than done, of course. But I think maybe perhaps leading by example of suggesting how you would manage this data, how you would go about making sure it's well documented would probably go a long way. All right, so it looks like it finished downloading the file. So my guess, if it's timing out, it might be a slow internet connection. Perhaps compress it in chunks might lead to faster downloads. I mean, not faster downloads, but compress into multiple files might make it easier to download it. All right, do let me know other questions that come up. But if I go back here to my text editor, let's examine the Git log where we left off. And where we left off was this final file. This final commit is what we did. This was the last commit we did together online, where we added things like a license, code of conduct, and the contributing guidelines. But in the meantime, I've made a couple other contributions to the project. And let's look at the commit. Let's look at the commit and let's make sense of those changes, right? The whole point here is to look at git log of a project and understand the evolution of the project. So hopefully I've written out changes that make sense, right? A commit message that makes sense. So the newest commit here is support local deployment of the application. All right, what does that mean? And what that means is that when we configured our project, we configured it to work on Heroku. But it won't necessarily do what we want to do if we deploy it locally. So I went ahead in a commit, I went ahead and supported local deployment of the application. So that's the commit message, but it doesn't really tell us what was the actual change. It's just a commit message. So it says, okay, looks like there is some sort of local support for deployment of application, but what was actually changed underneath the hood? Right, so let's go ahead and resolve that. So I can go ahead and do git show and the commit hash. Every commit has what is called a hash value. It takes the commit and it runs it through a hash function, so it has a unique identifier for every commit. And you could reference this commit through this unique identification. So let's go ahead and do git show, and let's type in that commit, this commit hash. And this is kind of long, right? You can copy and paste it. But luckily, you only have to write a couple of those characters of the hash, because Git is smart enough to say, okay, there is probably no commit hash that starts with 3005, so I know which one you're talking about. So I type in git show, and now it's showing me what was the change caused by that commit. So now you can see what we did. We modified apparently the make file. I had a small typo there. I should have done Python 3. Let's see. And I added a new rule in my make file that is going to deploy. It apparently runs this file, run app, for the deployment. So let's go make sense of it. Looks like I added a file called bin run app. And this here is going to run my Flask application locally. It sets up a couple of environmental variables to run the app locally. And then it proceeds to call Python -m Flask run. So it looks like I have a bash script that's going to deploy the application. And that's in a file called bin app run. I think that's what I call it. Yeah, run app. And if I look at, I also modify the app.py file. Import OS. I import retrieve local IP address. And then the way it's going to work is that when we run this application, it's going to look up for an environmental variable and look up the value of that environmental variable. So let's make sense what is an environmental variable, because I dropped it a couple of times. So let's make sense what exactly is an environmental variable. Let me take a look at the chat here. So I see that Eric is joining us from Unit 2. Eric, hopefully you enjoyed Unit 2. Hopefully you got a lot out of it. You are a fellow Unit 1 alum. So I guess, unfortunately, you guys missed me in Office Hours for Unit 2. But I was the voice behind those videos. Maybe that was a good thing. So hopefully you've learned a lot, Eric, in going through Unit 1 and Unit 2. And maybe you can put some words of encouragement here in the chat for those who are in Unit 1 who hopefully are wrapping up their mini project work to move on to Unit 2. All right, so I see Kinjal is here. Hello, Kinjal. Yes, we missed you. I noticed that you weren't here for a while. You always ask some good questions, bring up some good points. So I know I missed you, and maybe others missed you here. So to go through the rest of the week's office hours, I was wondering if there is a way to download the YouTube videos. You know what I might do? I might go ahead and just I might just download all. I might just, because I have the admin account, I might just download all of them and just post them on the shared drive. I might do that. That might take me an hour to do it all, but maybe that's a nice weekend project for me. So keep an eye open for the shared drive, because maybe I might do a drop of the YouTube videos. Okay, so I'm going to talk about the this idea of environmental variable. So you can think of your computer existing in some sort of an environment, right? So every time you hear an environmental variable, think of it as a variable that exists in your system, in your computer. You have variables that exist when you run, let's say, a Python application or a Java application, some sort of language application, right? Exists for the duration of the application. But then you have system-wide variables. You have system-wide variables that exist. And those are called environmental variables. And these environmental variables, they are going to reflect, I guess. They're going to govern how applications behave. So, for example, if I go into my pod and I do print-env, I call print-env, and what I show are all the environmental variables we have on your pod. All right, a lot of them, like Jupyter Hub user, some sort of URL, things like that, port numbers. All these environmental variables are system-wide. So the reason why we have this is because applications oftentimes make use of environmental variables. So what we had here in our project is we see this here, export Flask app equals this, export Flask debug equals true, export deploy equals local. What is that doing is creating environmental variables. So we're creating an environmental variable called deploy equal to local. And then what we do in our Python code is we get that environmental variable. So this is here we can control the behavior of our application based upon those environmental variables. So if it's a local deploy, in other words, running on our personal computer, sorry, we've defined an environmental variable called deploy. Drank the water too soon. Equal to local. Sorry about that. And then we retrieve that environmental variable. And then we check, is the environmental variable equal to Heroku? If it is, we get the IP address of the visitor. However, if that's not the case, if our local variable isn't equal to, our deploy variable isn't equal to Heroku, then it proceeds to recall this function we defined that retrieves the local IP address, the IP address of our personal computer. So notice we use an environmental variable to control the behavior of our application. So that's the changes caused by that commit. All right, let's do git log and let's examine git show. Let's examine what happens, this commit message right here. Sorry, that commit hash. So git show dd a7, that should be enough. And the commit message is called apply pep8 styling. There is a style guide for Python called pep8. We didn't have time to talk about it in the course, but do get familiar with the pep8 style guide. Here is the official link to the pep8 style guide, the official style guide of Python. And here is a article that I like that explains pep8. And the importance of pep8 is that if we all have we all code the same style, then our code would be more readable. And more readable code is code that is easier to maintain. So while we can write Python code very differently, it gives us flexibility. If we kind of agree upon a style, then we will lead to code that is readable. In fact, if you look at our project on contributing, I point out that any code you write should be pep8. So in fact, where it says git style, code style, follow the official coding style outlined in pep8 in real Python. So please, if you do want to submit a change to our project, I do ask that you have in pep8, and don't fear if your code isn't pep8. I can review your pull request and I can tell you, hey, this is what you need to do. So don't fear me saying make changes, because this is a learning experience, right? This is all about, this is more for educational purposes. So yeah, so it looks like what I did is that I noticed my code wasn't to PEP 8 standard, so I went ahead and modified it to be PEP 8 compliant. And let's do git log once again. And then finally I have let's look at that last commit. So git show, and then db 8db, and then it adds a readme file, which it just adds the whole file. And that here explains how to deploy all those nice things about our project. So that's how we can easily, the power of doing git log, looking at those commits, and do git show commit hash to see the change that was contributed. I see a lot of activity going on in the chat, so let me take a look at what's going on there. All right, apart from the grader, how can we run every other package and data on our local machines? All right. Yes, you need to do pip install them, and you already have Jupyter Notebook installed. And I see Anna is saying that just install Anaconda, you will have all the packages already installed. Yeah, so if you go to Anaconda, if you install Anaconda, it's going to have a majority of the packages we use. It won't have all of them, but it will have the majority. But what a lot of people like about Anaconda, and maybe is this Anaconda, this may not be, is this, okay. I guess the website just changed recently, and I was like, wait a minute, is this what I'm familiar with? Project, let's see, products, where is resources, solutions, pricing, Anaconda distribution, Python, how about that? Individual edition, there you go. So if you install this, it should have a majority of the packages you need. And there is a way in Anaconda to install additional packages. So you might have to do that. So if you run the notebook and there is an import error, a module not found error, then just make a note of that package and install it. The only thing you won't be able to do, I think, as Johnson pointed out, is the grader. The grader won't work. So, yeah, oh well. But everything else should. In fact, if you were curious to see what are the package versions we use for our course, you can call pip freeze. You can call pip freeze, and here are all the packages we use for our environment along with the versions. So pip freeze, there it is. All the ones we use with the exact same version. In fact, you can do pip freeze and then redirect that output to a file like, I don't know, I'll call it pip freeze output. And then you can go and download that file, right? You can go ahead and do that. Keep in mind that some of these packages probably might only work for Linux. So there are a couple packages that you might just have to ignore because they only work for a Linux install. You can do that. I would actually just recommend that you do, if you can do this, just to see what versions we use. But by all means, feel free to use perhaps newer versions. So, but that information is available if you would like to via pip freeze. All right, see, follow up. What about loading data to the local notebooks? Do I have to pip? Talk about the data we use for the mini projects. Just or for the mini projects and the other notebooks, just make sure it's available locally. You might have to change how it's loaded. So there might be some kind of changes you have to do with the notebooks. But I think, for example, if I were to go here and I would go to data course and I were to go into, let's say, data wrangling and perhaps pandas. Let's see if we have load up a data set. Let's see. Yeah, so just make sure you download the data. Keep in mind that if you're using Windows use different separators of, use a different character for separating the directories. Windows use backslash, Linux operating systems and Mac OS use a /. So there might be some adjustments you have to do to the code. Keep that in mind. So please make sure you download any of the data. That's what you should get when you download, when you zip up Data Course and you download it. It should come with all the data that we use. All right. One can even download Miniconda, isn't it? Yes, you can also download Miniconda. In fact, I use Miniconda. I don't use Anaconda. I use Miniconda. And even then, I only use it begrudgingly, to be honest with you. Yeah, I prefer other stuff. That's just me. Let's see. I see Eric. Yeah, looks great. Glad that you enjoyed those lectures from Unit 2. And I appreciate your kind words. All right. So if we go here, all right. So that's what we did for the project. However, one of the things I want to talk about is Docker. Let's talk about Docker. You may have heard Docker. It's kind of a buzzword. People like to drop it a lot these days. So let's briefly talk about Docker. And keep in mind, I am no Docker expert. So don't interrogate me about the specifics of Docker. But one of the problems we have is I can get an application to work on my personal computer. And maybe this application is rather intricate. Maybe it requires installing a lot of certain packages of certain versions, installing certain other programs, and it just may only be able to work on my personal computer. And I can write a README file and perhaps a make file that can help in the deployment of an application. However, instructions are only so good. Some mistake happens, there's some problem, and it's just difficult to replicate the build on your machine that was successful on my machine. And that's a common problem that has plagued software development, software engineering for years. You got it to work on that computer, but you can't get it to work on your computer. Right? We've all been there, perhaps. Maybe not. So, what we want to do is we want to use a solution called Docker. And what Docker is all about, Docker is going to help you create these things called containers. And your application exists within this container in your system. So here is your system, or your computer, system, local computer. And then we have an application that we have running in this neat little container. And just sort of like the idea of a virtual environment, we can isolate dependencies. And we can get our application to run on a virtual environment. Same thing here, but on a bigger scale. All right, we can have an isolated container where we can go in and have deterministic builds. We can have reproducible builds so that all that is required to get the application to work on your computer is to run this container. And this container, we have a set of instructions that tells a program called Docker how to construct the container. So Docker says, give me this file that I will follow it, which will replicate the container and have the application being run in that container. In fact, Jupyter Hub, the pods you are running, you're making use of, are built using a Docker file, built using Docker. Because we have defined a set of instructions that describe how do you create your account on our Jupyter Hub. So every time you hit make or enter server, whatever to start server, what it is, it's building a Docker container where Jupyter Hub, Jupyter Notebook is being run in. right? So we're using Docker, right? You may have not realized, but we're using Docker. So that's the goal. So let's go ahead and play around with Docker in our project. And the whole point here is that if we're able to build our application in Docker, then people who are using different operating systems can get this project running locally just by installing Docker. Right, this is a problem because I use Linux. You guys out there might be using Windows, Mac OS. I don't know what operating systems you guys are using. It could be a wide range of operating systems and versions, whatever. So let's see if we can create a Docker file in which, if we install Docker on our personal computer, we can create a Docker container that is running our application. So it's a lot easier for you to clone the repo and get the application running. So let's go ahead and do that for this last office hours. But of course, any questions that pop up in the chat, I will take a look at and I will address. Okay. So let's go into my text editor. And since we're going to create a new feature into our project, we're going to go ahead and implement a Docker deploy on our project. It's probably best that we create a branch. Let's not forget about that, right? Don't do things on the master or main branch. You create a branch that introduces those changes. So I'm going to say git checkout -b Docker. So this here is going to create a branch called Docker, and checkout is going to automatically have us change to that branch. So git checkout Docker. And what we need is to create a Docker file. And a Docker file defines a Docker image. So you have these two concepts in Docker. You have a Docker image and a Docker container. And you can think of a Docker image is kind of like a class. Remember, in object-oriented programming, we define a class. And a class is a recipe, a blueprint, an outline, a template, whatever you want to call it, right? It's a set of instructions that tells you how to create an object. Same thing with the Docker image. It's kind of analogous. You can think of a Docker image as a set of instructions that, if were to be followed, we create a Docker container. So Docker container is the actual kind of the physical manifestation. So we have a Docker image and a Docker container. Just like we have a class and we create objects of that class, we can create Docker containers from a Docker image. So keep that in mind. Think of class and object. That kind of helps out. Of course, they're not exactly like them, but I think that analogy kind of helps out people. So let's see. Let's go. And the first thing we're going to do is we're going to create a Docker file. So let's go ahead and create our Docker file. I'm going to create a file called simply Docker file. Simple file, just called Docker file. And what we're going to do is we don't want to create a Docker file image. Sorry, we don't want to create a Docker image from scratch. It'd be very tedious to do so. Instead, I want to create my Docker image based upon an already existing Docker image. And this is analogous to the idea of inheritance. Remember, in object-oriented programming, one of the things that I say is that very rarely we'll be creating objects or classes from scratch. Very rarely we'll be defining a class from scratch. What is more typical is we inherit from some other class. We build on top of that class. Right? This whole idea of standing on the shoulder of giants. In fact, you'll be doing it when you go on to Unit 2, which I really do hope you go on to Unit 2. You will be creating custom estimators. It's a scikit-learn concept. You'll learn about scikit-learn in Unit 2. You don't create estimators from scratch. You inherit from a base class and you build from there. Same thing in Docker. Typically, you don't want to create a Docker image from scratch. You're going to inherit from some other base image. And then you add the idiosyncrasies. What makes your Docker image different from a base image? So let's explore. And I'm going to go to Docker Hub. In Docker Hub, if we take a look at what it says, Docker Hub is the world's largest library and community for Docker images. So in other words, it's like a repository of images that we can, quote, borrow and use for our custom image. And we have official images for various projects. And what I'm going to look for, in fact, I can sign up for this service and host my images if I'd like to. But we're not going to go and do that. We're going to type in Python. And I'm going to look for, I'm going to see if I can find some image out there that has Python already installed, already configured. So it'd be a lot easier for me to get my application up and running. So I see one called Python, right? Let's examine it. All right. And I have these tags on the different versions. So notice I can choose different images that use a different version of Python. All right, this is exciting, right? And what I'm going to do is let's see what version we are using. So if I go back here and I go back to this here, remember there was a runtime txt file? And this had the version of Python that we used. And we used Python Python version 3.73. A little older version. We probably could have used a more modern version. In fact, we can probably do that fix, and maybe that's an issue I can raise on the repo, right? A good first issue to change the runtime environment. But let's go ahead and look for a Python, a Docker image that uses Python 3.73. That already has that version of Python installed. So let's go back to Docker Hub. And let's see, right, 3.7.9. I don't see 3.7.3. And maybe this is sample. Oh, this is simple tags. Well, maybe there's let's see if I can find. But notice they have a common name. The name of the version. If you're wondering what Buster is the name of a Debian distribution. Debian version, a version of Debian. Debian is a Linux distribution. So some of the things we have is something like 3.7 Slim. Let's take a look at that. And here is the Docker file that defines the 3.7 image. A lot of it is complicated, but this is why we don't want to do this from scratch, right? I hate to write this. I'm not sure about you, but I hate to write this. But this is a Docker image for Python version 3.7. And Slim just means it's a slimmed down version, which is perfectly fine for our purposes. So let's see. Okay, let me go back here. Let's see if I can search. Perhaps I can search 3-7, 3.7 -3, I think is what I had. Yeah, 3. Okay. Let's go back to our text editor. And what we're going to do is we're going to say from. And then we're going to say what is the image we want to inherit from. And the image we want to inherit from is Python 3.73 -slim. So this line here is like inheritance. We are inheriting from this image called Python 3.7.3-slim. And if we go back here, this is a Docker image that we're going to use, and guess what it does? It inherits from one called Debian Buster Slim. So the image we're going to inherit from inherits from another image, right? So we're building on top of giants in a way. So if we go back here, so we have that. So this here, it creates, we're going to inherit from this base image called Python 3.7.3-slim. Now what we're going to do is we want to copy our project file to a location in our container. So you can think of what we kind of have, and I know I keep on going back and forth between my editor and the browser, so sorry for kind of going back and forth. What we have, let's just draw a new picture. This is the big box. What I'm drawing here is our personal computer. And in our personal computer, we have our repo. Right? We have the directory of our code repo. And here we have a container that we want to create. And I draw it as I'm trying to draw it as like a box, right? Kind of crate in a way. Right? And this is my picture of a box. What I want to do is I want to copy this code into my container, so to speak. So the way I do that is if I go back to my text editor, I say copy dot to a location called app. So in my resulting container, you can think of it as an operating system. It's its own operating system. I'm going to transfer, dot refers to where I'm currently located, so my project location in my personal computer, transfer all those files to a directory called app on the container's operating system. So that transfer the things we want, and then I'm going to use workdir, and workdir tells Docker what is going to be the working directory of the container. So we transfer the contents of our project to a location called /app, and then we say workdir /app. We're telling our Docker that the container, the files we're going to look at, are in this directory. And then what we're going to do is we need to install our project requirements, right? You can think of, we have an isolated environment. We need to install those requirements. And we know how to do so because we have a requirements.txt file. So I'm going to say run. Run here is going to specify a command that's going to be run in our container. Pip install -r requirements txt. All right. So now you can think of, we have here, when we create a container, we copy over the contents of the project to that container, and then we proceed to install the packages set up in requirements.txt. I'm going to hit save, and do let me know if there are any questions right now. I know it's kind of a lot of stuff, so do let me know if there are any questions. So our image isn't just ready to go, but we're going to try it out. We're going to see what we can get, what we can get running. So we define our Docker file, and what we're going to do is we're going to first build the image. So I'm going to say Docker. First of all, you need Docker installed on your computer, of course. So I do Docker build. This here says a self-sufficient runtime for containers. Right? This is going to help us build our containers. So I say docker build -t. We're going to tag the image as WQU app. And where are we going to do it? Dot. In other words, we're telling Docker that the location of the Docker file is where we're currently located. That's what that dot means. And here it's constructing our Docker image. And notice how it's pulling from library-python because it saw that top line. And that top line, if I look at here, top line says, hey, go ahead and pull in that image. And let's look at else. It ran copy dot to /p/app. So it's copying over the contents of our repo to what would be our container. And then it specifies the work directory, and then here it is installing the packages. It's running that command. And look at the code there. It's installing those packages. And it says, all right, successfully built, and it's called WQU app. So I can say docker image ls. And docker image ls is going to show us all the Docker images that I have created. So this one was just 40 seconds ago. This one was 17 months ago. You're like, did I do this 17 months ago? And the answer is no. But this here is that Docker image that we inherited from. This Docker image that we just built right now is built on top of this one here. Even tells us the size, 140 megabytes, 170 megabytes. So now we have a Docker image. What we do next is we create a Docker container of that image, a realization of our image. So let's try that out. Let's go ahead and talk about how we can go ahead and create a container of our image. And the way it works, we say docker run, and then we say the -d option. Let's go ahead and refresh my memory what -d is. Detach, run the container in the background. We're going to let the container run in the background. And this is going to allow us to have control, return control. Because if not, then then my command line is going to be stuck. So docker run -d. And then the name of the image, which I call WQU app. Tab autocomplete helped me out there. And there we go. It built our Docker container, and it's nothing too exciting, right? Nothing really happened. It just gave us some sort of hash, apparently. So if I say docker container ls, this here lists my running Docker containers. But I don't see anything. And the reason why is because, well, I've created my Docker container, but it doesn't do anything. Notice the last command we ran was run pip install -r requirements txt. It installed the requirements, and it's just sat there and didn't do anything. Nothing is really happening in this project here. So nothing exciting. We have to say what we want to do in our container. It's just going to sit there and nothing happens. There's no real application going on. All right, let me experiment. I'm going to do looking at some documentations. Okay. Let's see if this works. Let me just look something up. let's see. No container. Yeah, because it's shut down. Okay. Sorry about that. So let's go modify our Docker file. Because what we need is to tell it what it should do when it creates a container. And what we want it to do is we want it to run our Flask app. Notice we haven't set it to run our Flask app, which is what we want to do. So let's go ahead and fill out that missing piece. And I'm going to say cmd and bin, it's cd, and let's see, what was that command to run it? But in fact I had a script. Remember, I have a script in bin run app. I say, I have an app, I have a script that I should probably run. To get things going. So let's try that out. Let's see what were to happen. So I go here and I'm going to say docker build. All right, goes through the process once again. And let's go ahead and do docker run. So I had to rebuild my image since I modified it. And this should go ahead and, all right, let's do docker container. And now I see I have a container. I have a container running right there. And it tells in fact, let me just blow this, make this all in one. Let's make this bigger to make it a little easier to see. Let's see. Docker container ls. I thought it'd spread out. Do I have this as one screen? Yeah, I do, but oh well. A little hard to read, but I have things like container ID, the image, and the container name called determine query. And let's say I want to enter that container. So let's go ahead and do docker exec, execute, and then I should say think -t, and then bin bash, maybe it's just shell. No such, what's the container? Okay, now what I've done here with this command is I have entered my container. Remember, in this picture here is we have our operating system and we have the container inside our operating system. So now what I've done is I've entered that that container. And I type in ls, right? I can navigate. Hey, there's my project, right? There's my project. I can do cd dot, which takes me to the root directory, the immediate parent. Type in ls, and here is my container. And here are the files that belong to my container. It's an operating system, basically. And notice there is a directory called app because that's where I transfer the contents of my project in. So if I cd into app, here are the contents of my project. And then I can do pip freeze. Do pip freeze, and there are the packages that are installed in my Python environment. Which makes sense because I ran that pip install requirements.txt. So, So it looks like what I've done is I have kind of a mini operating system in such a way where my application is running. In fact, let's see if I type in, there's no top. All right. I type in exit, so I've quit. I am back to the surface, so to speak. And let's go ahead and get our, okay, so so my container's running, but where is my project, right? Where is my project? Isn't it up and running? Well, the answer is no, it's not. Well, it's running, but I have no way to access the project. I have no way to access the Flask application. And the reason why is because I haven't exposed any ports. So remember when we go onto our Flask app, we go to localhost colon. Remember we did localhost colon 500, 5000. What follows the colon is called the port. And you can think of a port as a port of entry. You think of our computer has said, hey, I've opened up a port named 5000. That's where you can communicate with the application. But if I go to localhost 5000, it says site cannot be reached. So the problem here is that my container is running, my Flask app is running, but I haven't exposed any ports. So it's running, but there's no way for me to connect to it. So what I need to do is I need to fix that. And the way I fix that, the way I can expose a port is within the Docker file. So after I run pip install, I'm going to expose port 5000. So now that port should be open. Now I'm able to communicate with my container because my container has exposed that port for me to access. And then let's see, let's try this out. Go back here. So let's go ahead and build our image once again. We have to build it because we modified it. So Docker build. And then let's go ahead and run my container. Let's create a container. Something I have to do that's going to be a little different is that I have to do -p. And if I look at the options, let's look at the documentation to understand what P stands for. Publish a container's port to the host. So we tell it we're going to map. What's going to happen is we're going to map. If I say Docker run, we're going to map our container's port 5000 to our system's port 5000. So that when we visit our computer's port 5000, it's actually redirecting to our container's port 5000. And the way we do that is through the -p option. -p 5000, 5000. This map containers port 5000 to our ports 5000. And then what follows next is the name of our image, which is WQU app. And now our project should be running. So let's try that out. Let's go to localhost 5000, and that is not running. And let's see. Let me just modify something. Site can't be reached. So let's see what is the issue. And I think give me a sec while I'll figure this out. Alright, I think it's because when I call Flask, I have to specify host to be slightly different. I think my host should be this. Let's see if that works. Okay, what I need to do is I need to kill some of those Docker containers. So if I do Docker container ls, here are all the containers that are running. I need to kill some of them. I can do Docker container container kill and the name of the container. So I've killed them, shut them off. Let's try that again. Let's try this out now. Okay, bingo, there it works. The issue is because when I run Flask, I need to, in my Docker container, need to specify this option, host to be 0.0.0.0. And probably I should go ahead and probably modify this script, but that's always a change I need to do. I'm not sure why it has to be that case, to be honest with you. But that's the fix. And now, this application, it's not running in my system, so to speak. Well, it is, because it's the Docker container exists in my system. But it's actually being run, more specifically, in a Docker container. And then I was exposed to port 5000. I mapped it to my system's port 5000. And able to communicate to the Docker container. So now, with this Docker file, if someone has Docker installed and they follow the commands that we did, Docker build the image, Docker run a container of that image, they should have this project be able to run, not have to worry about the proper operating system and all these different configurations and whatnot. We've defined how to create a container that is going to run our application. So now our project is portable. And that right there is a crash course on Docker. So hopefully we've broken the seal, we've broken the barrier, so that when you can go ahead and be more confident in learning Docker if you want to learn more about it. Right? You've seen some of it, so when you see it again, hopefully it'll be a lot easier, a lot straightforward. Clarify some of those tricky points. So let me know if there are any follow-up questions here. I see Lyndon Smith, so glad you're able to download those files off the pod. That is, happy to hear that. Let me know if there are any questions. It's the last office hours, so I don't mind going a little over. I don't have too much of a prepared last words. But thank you, everyone, for coming to office hours. Thank you for bringing up questions, bringing up topics. I really hope that you can today, or whenever you watch this video, look at where you've come from, right? Back in, was it September, right? The end of September when the course started. Towards the end of September, in fact, I didn't go to the first 2 office hours because I was doing a training in a UK time zone. So I was unavailable for 2 of those first week office hours. But I really hope that you can look at where you were before and look at wherever you are now when you watch this video, and really do feel you've come a long way. And feel that while you may not have understood everything to 100%, you feel like you've made progress. You've moved the ball, so to speak. You are in a better position. That you've been exposed to a lot of knowledge. That while at times you don't get it 100%, you feel confident enough to pick it up again, or look additional resources, or more prepared to see it once again, or more confident to advance your knowledge. I really do hope you can look at that and say, wow, I've learned a lot. I may not have understood everything, but I am more confident moving forward in my data science, my coding, my technical career. And I really hope you feel that way. And I really hope that you finish up your mini projects so that you can move on to Unit 2, right? The learning isn't over. We're just scratching the surface. I know it can be a bit overwhelming because there's so much to learn. And I always sometimes feel like, man, there's so much to learn. I wish I knew these topics really well. Right? I personally feel that way. Maybe that's reassuring to know that I feel that way. But I'm always constantly learning, always constantly improving. So I do appreciate you bringing up your the questions and topics we can discuss in office hours. One of the things I try to do in office hours is go through the mini projects so we can work on them and learn how to tackle them. And also learn additional topics and skills that aren't directly covered in the course content. Right, and that was what I was trying to do with this kind of project we did for the last 2 weeks. And we have a very bare bones project, right? It's nothing too fancy, right? In fact, if you look at my browser, right, it just says, hello, the temperature. but it used a lot of cool skills, right? If there was version control, there was writing good code, separation of concerns, there was Flask that we learned, there was web APIs that we learned how to use. But this is really just a template, right? This is here. What I really want you to do is you can take the code we have in our repo and do a completely different project, completely make it your own, or contribute to this project. So I do want you to take the time and contribute to this project, right? It's a collaborative effort. I think one of the best ways to learn is by doing and by trying, by engaging with the material. So I think this is, hopefully you feel like you can contribute, do things. By the way, I'm off next week, so I may not get to any issues or any pull requests you have for the project. So I do ask for your patience. So yeah, that's basically what I want to say. Let's see. Let's take a look at the chat. Thank you, Timur, for the kind words. Thank you, Paulo, for the kind words. As well as Soon Johnson, Shakiba, thank you. Gita, yeah, it does feel that way. Thank you for everything. Naya, nice to meet you guys. Joseph, yeah, thank you for the kind words. And I hope you can meet each other again in Unit 2 next calendar year, right? Let's hope 2021 is a better year for everyone compared to 2020. I really do hope so. So with that said, any last things we want to bring up right now? I will probably post on the forum a list of books and resources that I personally like. I know someone said there's ways to download YouTube videos. You can look into that. And maybe if I'm feeling, maybe if I got an hour to burn on tomorrow, maybe I can just download all the videos and post them up on the shared drive. Maybe I'll do that. Right. Anything else we want to bring up before we conclude? Maths for part 2. Linear algebra. Get it's if you want to do some refresher to get ready for Unit 2. Linear algebra, matrix multiplication, matrix operations, things like that. That's what I recommend. Linear algebra. I will post some resources on the forum, so keep an eye on that. If there's anything else you can post on the forum, I will probably take a look at that as well. So anything else you want to add, post on the forum. And with that said, take care. Have a good rest of your day. Have a good Friday. Have a good weekend. And perhaps this isn't our final goodbye. So I'm not going to say goodbye because we'll meet again sometime, I guess. Let's not close the door there. Would you mind if we disturb you with questions after now? You can always ask me questions, right? Keep in mind that I might get just busy, may not be able to address them, but you can always ask me questions, right? There's no harm in asking. I won't get mad if you ask. How about that? But keep in mind that I have other responsibilities and other modules and other cohort starts, so maybe your question may not be on high priority, but there's no harm in asking. Okay, guys. I guess we'll see you around and have a good rest of your day, good rest of your Friday and weekend, and hope to see you guys in Unit